Hey everyone, if you've ever felt that determinants are just a massive headache of tedious calculations, you're about to see them in a totally new light. Today we're going to unlock how this one single number can be a secret weapon for boosting your scores in board exams and competitive tests. Let's dive right in. So, why should you even care about determinants? Well, the numbers on the screen pretty much speak for themselves. In your CBSE exams, you're looking at 5 to 8 marks. For the NDA, that's 3 to 5 questions every single year. And for JEE, you've got direct questions in mains and their key components in advanced problems. The message is crystal clear. Getting good at determinants is absolutely crucial for a top score. So, what even is a determinant really? Well, imagine a matrix, that grid of numbers, has a single secret number hidden inside of it. A unique value that holds the key to its most important properties and can solve some incredibly tricky problems in just a few simple steps. That secret number, well, that's the determinant. Okay, so formally, a determinant is a unique scalar value that's associated with every single square matrix. And remember, it's only square matrices, 2 by 2, 3 by 3, you get the idea, that even have a determinant. This number isn't just random. It's calculated from the elements of the matrix, and as you're about to see, it tells us a ton about the matrix itself.
So here's our game plan for the next few minutes. First, we'll find that secret number by learning how to actually calculate it. Then, we'll learn the rules of the game. These are the properties that'll save you a massive amount of time. After that, we unlock its superpowers, the real-world applications. And finally, we'll cover some pro tips and pitfalls for exam day. Ready? Let's go.
All right, first things first, how do we actually find this secret number? It all starts with the calculation, and the method really just depends on the size of the matrix. For a 2 by 2 matrix, it's so simple, it's beautiful. You just multiply the elements on the main diagonal, that's top left to bottom right, and then you subtract the product of the elements on the other diagonal. So it's just AD minus BC. That's it. That's your determinant. Easy.
Now, for a 3 by 3 matrix, we use a method called expansion. And look, just think of it as breaking down a big problem into smaller ones we already know how to solve. We pick a row, let's just say the first one for now. For each number in that row, you mentally cover up its row and its column. What's left is a little 2 by 2 matrix, right? We find its determinant, which is called the minor, and multiply it by the number we started with. You do this for all 3 numbers in the row, but here's the trick. You alternate between adding and subtracting the results. It sounds a little complicated, but it's really just doing that simple 2 by 2 rule 3 times.
Calculating is one thing, but the real magic, the stuff that gets you ahead in exams, comes from understanding the properties. Seriously, think of these as cheat codes for determinants. They let you simplify really complex problems and, a lot of the time, find the answer without any long calculations at all. This is exactly what examiners love to test. Let's start with the easiest ones. I call them the zero rules. If you spot any of these 3 conditions, you can just stop and immediately say the determinant is 0. Done. So, if an entire row or column is filled with zeros, it's 0. If 2 rows or 2 columns are exactly the same, it's 0. And if one row is just a multiple of another, like row 1 is 1, 2, 3 and row 2 is 2, 4, 6, the determinant is also 0. Spotting this will save you so much time. Okay, so what happens if you swap 2 rows or 2 columns? It's a simple but super important rule. The value of the determinant stays the same, but its sign flips. So if the determinant was, say, 10, and you swap 2 rows, the new determinant is negative 10. Simple as that. All right, listen up because this next one is a classic JEE exam trap. If you multiply an entire n by n matrix by a number, let's call it k, the new determinant isn't just k times the old one. No, it's k to the power of n times the old one, where n is the order of the matrix, like 2 for a 2 by 2 or 3 for a 3 by 3. Forgetting that little exponent n is one of the most common mistakes students make. Don't let that be you.
And here it is, the big one, the most powerful tool in your entire toolbox. You can take a multiple of one row and add it to another row. And guess what? The determinant does not change at all. Why is this so insanely useful? Because you can use this trick to strategically create zeros in a row or column, which makes expanding the determinant incredibly easy. This is a game changer.
So we can calculate them, and we know their properties, but what are determinants actually good for? Let's unlock their superpowers and see the incredible problems they can solve in a flash.
First up, geometry. Believe it or not, you can find the area of any triangle just by knowing the coordinates of its vertices. You plug them into a specific 3 by 3 matrix, find the determinant, take half of its absolute value, and boom, you have the area. And what's really cool is the bonus trick. If the area turns out to be 0, it means that 3 points don't actually form a triangle. They all lie on a single straight line. They're collinear. So cool. The determinant is also like the gatekeeper for a matrix's inverse. The rule is dead simple. If the determinant of a matrix is 0, we call it a singular matrix, and it does not have an inverse. End of story. But if the determinant is anything other than 0, it's called non-singular, and an inverse exists. This is a fundamental idea that connects determinants directly to solving systems of equations. And that leads us right into Cramer's rule, which is a really powerful shortcut for solving systems of linear equations. The process is pretty straightforward. We calculate a main determinant, d, using the coefficients of the variables. Then we find dx, dy, and dz by just swapping out each column one by one with the constants from the equations. The solution for each variable is then just a simple ratio. It's so elegant. And this is where the full power of Cramer's rule really shines. The values of those determinants tell you everything you need to know about the solution. If d is not 0, boom, you've got a unique solution. If d is 0 but one of the others isn't, there is no solution. And if all the determinants are 0, d, dx, dy, dz, you have infinitely many solutions. This table right here is your roadmap. All right, we've covered the what, the how, and the why. Now for the most important part. How do you translate all this knowledge into marks on the page? Let's talk strategy. Okay, this is all about smart preparation. For CBSE, your focus should be on showing your work with clear, step-by-step solutions, especially for questions on properties and Cramer's rule. In the NDA, speed is everything, so you have to commit those properties to memory. For JEE Main, train yourself to spot shortcuts and quickly identify singular matrices. And for JEE Advanced, you gotta be prepared for more complex, proof-based questions that really test your deep understanding of how all these concepts connect. Let's just make sure you don't fall for these common traps. We've hammered home that k to the power of n rule, right? Remember the small but crucial difference between a minor and a cofactor. It's all about remembering the plus-minus sign pattern. If you find that d is 0, don't just jump to a conclusion. You have to check dx, dy, and dz to figure out if there's no solution or infinitely many. And a simple one, area is always positive, so please remember to take the absolute value when you use the determinant formula for a triangle. So, what's the big takeaway from all this? At their core, determinants are all about pattern recognition. From spotting one of the 0 properties to applying Cramer's rule, your success really depends on seeing the pattern and choosing the right tool for the job. That secret number we talked about at the beginning? It isn't so secret after all. It's a key that unlocks a whole world of patterns. The more you practice, the more patterns you'll